Roland Pruitt.
Hey, I'm Joshua Hill.
And Kyle Thompson.
Hey, what we're going to do today is we're going to explain how the law of gravitation can affect the muscle when it's being worked out, in particular the mass versus gravity, and how once you center the gravity out, it can also help develop a better muscle. Roland here is going to do the demonstration. I'm going to do the explanation. All right. So Roland is doing a bicep curl here. Now notice when he's doing a bicep curl that he's going up and down in a smooth rotation. Hold on 1 second. Put a lighter weight on.
Talk louder.
Alright, notice when he's doing the bicep curl, how his body is totally in line. Now, if he pauses the bicep curl right here, then this is where the center of gravitation is. Once he brings it up, notice how his arm goes back and there's no longer a center of gravitation, which means ideally the bicep muscle is not getting as much work. So if he went back down right here, the arm is actually a lever, and once again this is where the center of gravitation is, which means this is where the bicep is getting its most work. A lot of people when they work out, they will pause and then complete another movement, and then pause and then complete another movement, totally manipulating how gravitation can help develop the muscle faster. The idea of working out is to exhaust the muscle and break down as much muscle fiber as possible. But by making a simple adjustment, we can have gravitation go on outside and in fact fatigue that muscle even more and get a better muscle development. And by doing that, instead of him standing straight up, we're going to have him lean forward just a little bit more. And now once he does the bicep curl, remember the center of gravitation is right here, but once he brings it up more, you can see the center of gravitation remains the same. Once he comes back down, there's a pause, and come back up, the center of gravitation is the same, thereby causing a greater effect on the muscle and giving greater results. Once you bring it back down, if you were to change the mass as well as center off gravitation, then you can actually see that it's a little tougher for him to lift, and at the same time he's totally using gravity on his side to fatigue that muscle and to build that muscle.
That's good.
Ready?
Yep.
Alright, this right here is the bench press. This is a regular bench press. What he's doing right now, he's pushing directly up from the surface of the board. So this is, the bar is 45 pounds, each weight is 45. Times that by 9.8, which is gravity, and that's exactly how much weight, force that he's pushing up on this bar. Now, what he's doing is like he's taking the muscle right here and he's working that muscle, exhausting that muscle without any other type of manipulation. All these weights in here are manipulating gravity. And what this is taking it, like I said, directly straight down. It doesn't have any tension. It's just a straightforward push up with the weight. That's it.
Hey, thanks a lot. Thanks, man. I appreciate it. Hey, you want these plates back on? Yeah.
This right here is called the incline bench press. On the other bench press, he was working this front chest right here. But on this one, he's working the front deltoids right here.
And the top chest.
And he's also working the top chest right here. So, as you can see, it's on an incline. So when it's on an incline, he's not pushing directly forward from the bench. He's pushing at a different angle on where he's working out his muscles. In this case, he gets a different workout from the bench press. And it also, as you can see here, like the angle is more like I say 120 angle. It's not directly a 90-degree angle. Therefore, like, it's just a different workout. They work completely two different muscles.
Don't pause it yet. You still got it going, right? Okay. Now also, once you change the actual gravitation and the incline of the bench in the workout, not only do you add in different muscle groups, but what's important to understand is the mass had to go down. Because you had a flat surface and gravity is totally on your side, where you had two 45s over there, we only got two 25s. because gravity is going against us, it's a lot harder to match that same mass with this mass when less of that particular muscle is being used, which is why we downgraded the mass, because we changed the exercise.
And he has to actually spend muscle on keeping the weight from going actually forward and to keep it going straight up, opposing to gravity at a different angle.
Exactly.
So that's way two different bench presses and way two different exercises. All right, go.
All right, so here we have a subject working his upper biceps and his deltoids again. And what makes this workout a little bit more complex is that he has to match the force of gravity plus his weight just to pull himself up and down. And because his muscles are so concentrated in this motion, it takes a lot more effort than any of the other exercises that we've shown you today. And Henry is, as you can see, this is a tiring exercise because of what he has to do.
Also, what happens is he's actually using a different muscle group. He's got his biceps going on here, but also he's working his lats and his rear deltoids, right? Now these muscles are a lot smaller, so it's going to take a lot more effort to match gravity and to bring himself up. Now we wanted to add mass because some people are strong in these particular areas. Then what he would do is put a dumbbell between his feet, and that'll be added mass, which will increase the effort that's used to match these exercises and to work out the muscles in a better position.
And also, you know, sometimes like in the military where people do more pull-ups and stuff, their bodies are more fit and they probably lay less than other people do.
Okay.
So that way that they have their muscles are stronger, but also they have less weight to pull up. So as you know, we calculate weight by his own body mass times 9.8, and that equals a force.
Okay.
And like Roland said, it takes just about double the amount of force was pulling down on him to pull himself all the way back up, because he's taking on that full-fledged gravity all the way down, and he has to pull himself all the way back up. So this is, like he said, it's a very tiring workout.
Okay. You can see the look on his face. He's actually pushing it out and giving it an assertive effort. And this is extremely tough exercise, as I said. And we want to sincerely thank our subject, Henry, and wish him well in all his present and future endeavors. Thanks, partner. You got anything to say?
No, just stay strong out there, keep on working out.